Hey y'all, welcome to our 2.2 video, Characteristics of Quadratic Functions. Today we're going to look at two different forms of quadratics. In 2.1 we looked at vertex form, and today we're going to look at standard form and factored form. So in standard form, you can see that we have three terms. The first term is always going to be our highest power, or that x squared term. And what's most important for you to recognize in all of these forms is that this a value that we saw in vertex form and we will see again in factored form, it means the same thing in every single form, and that's why we use the same letter for it. So that leading coefficient a is always going to determine the size and the direction of the parabola. So as long as you remember that graphing trick where for the parent function of a quadratic, how we can go over 1 up 1, over 1 up 3, over 1 up 5, and that pattern will continue for the points on one side of our parabola. We can use that trick no matter what form our quadratic's in. Okay, so in order to use that trick, though, we need to know where the vertex is, and we can start by finding the axis of symmetry. And in standard form, hopefully you've seen this formula before, but in standard form, that axis of symmetry formula is negative b over 2a, and that is what tells you where that x value of the vertex is, which is also the equation of our vertical axis of symmetry. So then to find the other point of the vertex, we are just going to plug in that negative b over 2a value into our function. So we can see that negative b over 2a. If I plug it into the equation, or f, my function, that's going to give us the y value of the vertex. And then from the vertex, we can use a to determine the size and direction of our parabola. Another super fast way to graph, and something that ACT loves testing you on, is knowing that the value c in standard form is going to be your y-intercept. So just another really important connection to make, because that'll make your life speedy and better. Okay, so example 1 tasks us to graph this function either using a table or properties of symmetry. And I just want to emphasize again that using a table, this is really our worst case scenario. It will work for any function, but it is slow. And so we like to avoid making a table if we can. So we're going to focus on using properties of symmetry. Okay? And in order to do that, we need to start with the vertex. So to find the vertex, I'm going to start with the axis of symmetry. So I'm going to abbreviate that AOS. So my axis of symmetry is going to be negative b over 2a. So let me go through and highlight. Here's my a value. Here's my b value, is going to include that minus, because it's really a negative that belongs to the 4. And c is going to be negative 2. So here's my value of a, b, and c. Okay, so negative b over 2a. And you can use your calculator to simplify this if you need to, but we end up with 4 over 1, which is just 4. Okay, so that's my axis of symmetry. We also need to find the y value of my vertex. So that y value of my vertex is going to be plugging 4 into my function. So let's go ahead and see what that looks like. 0.5 times 4 squared minus 4 times 4 minus 2. So we end up with, let's see, 8 minus 16 minus 2, which ends up with negative 10. Okay, so now I know that my vertex, the x value is 4, the y value is negative 10. So that was my axis of symmetry and my vertex. Okay, so let's go ahead and graph that. So 4, negative 10. Another shortcut I can use, remember I pointed out that the C value is your y-intercept, so my y-intercept is going to be -2. We can use properties of symmetry to say that that is 1, 2, 3, 4 to the left of my vertex. It's a little bit more obvious if we draw that axis of symmetry in there. There we go. So then 1, 2, 3, 4 to the left. So I know that that point also has to be on my parabola. I'm also going to go ahead and use the pattern I was referencing earlier. So normally my pattern is I go up 1, and then I go up 3, and then I go up 5. Okay, A is positive, so I'm definitely still going up. But now I have a vertical compression by 0.5 or a half. You know I like fractions better. Okay, so I'm going to go ahead and multiply this pattern by my vertical compression. So now I'm going to go up a half, and then I'm going to go up 3 halves, and then I'm going to go up 5 halves. So let's see what that looks like on the graph then. Okay, so I'm going to go over 1, up a half, over 1, up 1, 2, 3 halves, over 1, up 1, 2, 3, 4, 5 halves. Just to prove that this pattern holds, I'm going to go over 1 and then up 7 halves, over 1, up 1, 2, 3, 4, 5, 6, 7, and it lines right up with that point I already knew was on my parabola. So I can go ahead and use my property of symmetry to fill in the rest of those points. That is certainly enough for us to connect those just the best we can. Oh my goodness, not the prettiest, but you can tell what points I intended that line to go through. So that is what matters. Okay, so I graphed that function in standard form, really the same way as vertex form. We just had to use that extra formula to find the vertex. Okay, something that is super important in this course is to recognize that when a parabola opens upward like this, we call this value at the bottom the minimum, because it is the smallest value that the parabola can equal. It goes up forever, so there is no maximum value on this parabola. And while I'm thinking about it, we were supposed to label the vertex and axis of symmetry. So my vertex was at 4, -10. My axis of symmetry was at x equals 4. Beautiful. Okay, so that's what these next little notes. When the parabola opens upward, we have a minimum. When the parabola opens downward, when a is negative, we call that value the maximum value. Okay, so in this next example, all we have to do is just look at that a value and determine, is our parabola going to have a maximum or a minimum? So in all of these, I'm just looking at that value of a. And this first example is in vertex form, but like I said, a is the same no matter what form we're looking at. So a is positive, meaning my parabola is going to open upward. And the lowest point is at the bottom. That is definitely going to be a minimum value because that vertex is at the bottom. Okay, again, I have a positive a value, so I know that parabola is going to open upward. I'm not trying to represent the stretch or compression on these, just whether it opens upward or downward. So again, that vertex is at the bottom, so that's going to be a minimum value. And in C, a is negative, which means I have a downward facing parabola. The vertex is at the top, that's going to make that value a max. Okay, in this next example, determine whether each function has a maximum or minimum, determine the domain and range, and the intervals of increase and decrease. Sketch the general shape and location. Okay, so I do, in order to do the general shape and location, I do kind of need to know where the vertex is. So A, you could claim it's in vertex form or in standard form, right? Either would be okay. I'm going to go with vertex form though, because if I rewrite this a little bit creatively, if I rewrite it like this, we can tell that vertex is at 0, 0. And then just by using that a value, I can tell that the parabola opens upward. I don't care about how much it's stretched. I just care about a general sketch. It's upward and I have the vertex in generally the right spot. Okay, so it definitely has a minimum value. My domain is all real numbers. My range, this is why it's important to know where the vertex is. My range starts at 0 and it goes up forever. Okay, remember intervals of increase and decrease. We've already made this note, but remember that intervals are always using x values. Because remember, x values are like my when or where. It's more like a time because x's are our inputs. So the interval of increase is when this parabola has positive slope. So I definitely have positive slope on this side. So I'm looking for these x values. So I would say that it is increasing from 0 to infinity in terms of my x values. And it is decreasing on the other side there from negative infinity to 0, right? Let me highlight that for you. Right, so decreasing because my slope is going down because we read from left to right, and that corresponds with these x values over here. Okay, let's go on to B. So B is definitely in standard form. You could change it to vertex form, but we're going to do that in a couple lessons from now. So for now, I would say let's just go ahead and do that axis of symmetry formula. Negative b over 2a, which is going to simplify to 3. Okay, so I'm going to call that 3. I do need to find the y value though, right? So y is going to be plugging 3 into my function. This function's name is g. Oop, I'm plugging 3 in. So this function's name is g, so I need to plug that into the rule for g, so negative 3 squared. So notice, this negative is not going in parentheses, because the only thing that would go in parentheses is my input. My input is a positive 3, the negative stays in front. I am only squaring the 3. And that's what's going to cause the parabola to open downward. And then plus 6 times 3, and that is going to equal 9, I believe. Okay, so then my y value is 9. I have a negative a value, which means I know my parabola is going to open downward. So again, it doesn't have to be perfect. The y-intercept definitely is not correct. The y-intercept is the c value, right? So c is 0. So the y-intercept should be 0. For a sketch, unless I specify I'm looking for a y-intercept on your sketch, it does not matter. We definitely need the vertex, but everything else is just gravy. Okay, so this has a maximum, right? Because the vertex is on top, right? That's a max. Which really is referring to my range, right? Because my range has a maximum value. It goes down forever, but the maximum value that my function can equal is 9. So that's why we call it a maximum. So 9 is my max value. Okay, I am increasing when I have positive slope. So this side has positive slope. So from negative infinity to 3. And then I am decreasing for the other half of the parabola there, right? So these are the x values where I am decreasing. These are the x values where I am increasing. Okay, I suggest you pause the video right now, see if you can do C by yourself, and then you can catch back up and fast forward if you got the right answer. So I'm going to go through this one. If you use the axis of symmetry formula, because we are in standard form again, we end up with an x value of 2. We plug 2 back into my function. I'm going to do some of the math in my head here because I don't have a ton of space. Okay, so 2, 1. I can see A is positive, so I definitely have an upward facing parabola. If we wanted to, we can say, oh look, wow, that y-intercept's 9. It has a minimum value. Domain is all real numbers. Range has a minimum value of 1, but it goes up forever. I am increasing on the right side of my graph, and I am decreasing on that left side. So hopefully you got that, and we can speed right along. Okay, intercept form. So intercept form can also be called factored form. I think that's what I tend to call it. And again, A means the same exact thing. It means the same thing in every form. It determines the size and direction of our parabola. Okay, in factored form, our factors, so let's see, I'm going to underline these. So our two factors help us to quickly identify the x-intercepts. So our x-intercepts are going to be at m and n. And just like everything else that goes in parentheses with x, it's always going to have the opposite sign than it does when we are interpreting that value. So just like the vertex has the opposite sign for the x value, all of our transformation rules are opposite with the x value. M and n will also have opposite signs. Oh, and I forgot to fill out that last blank, the axis of symmetry is always halfway. It can be found using this formula. Basically, you're just averaging the two intercepts together because you know the axis of symmetry has to be exactly halfway between your two intercepts. There we go. So that's a handy equation to have. Again, that's also the x value of the vertex, so we can add that my vertex is going to be at m plus n over 2, comma, f of, right, because I'm going to plug that x value into the function to find my y value. So that is my vertex. Okay, so example 3, graph using the vertex and x-intercepts. Label the vertex and axis of symmetry. Let's not forget to do that this time. So let's look at the vertex first. So we'll use that handy formula. Actually, before I do that, side note, right, here's my values of m and n, which means that my x-intercepts are going to be at 4, 0, right, opposite sign, and -2, 0. So let's go ahead and put that on the graph already. 4, 0, -2, 0. So 4, -2. And again, I know because of the property of symmetry, I maybe don't know what the stretch is yet, but regardless, if I make a parabola, whether it's upward facing or downward facing, I know that the axis of symmetry has to be exactly halfway between those two intercepts. Okay, so let me erase that real quick, sorry. So -2 and 4. I already know, because I was drawing that on there, right? The axis of symmetry halfway is going to be at 1. But let's do that using the formula just to verify. Equals m plus n over 2. We end up with 2 over 2, which is in fact 1. How exciting. Okay, so then we need to find the y value of that vertex. So then y equals f of 1, right? I'm going to plug 1 into the function to find the y value. And we get -1/3 times 1 minus 4 is -3. 1 plus 2 is +3. And multiply that all out, and we get the y value is 3. So my vertex is going to be at 1, 3. So let's go ahead and put that on there. 1, 3, and I'm going to label it. I'm going to go ahead and label my axis of symmetry. And I can already tell, just from these two pieces of information, that I have a downward facing parabola. Okay, if we want to verify and add some more points on there, we can still use that graphing trick. The fact that my pattern, since I know it's downward facing, I would normally go down 1, or actually let's even start with up 1. You know what? Up 1, up 3, up 5. But now I have a flip and vertical compression by, and my factor for both of those is -1/3. Right? So if I multiply each of these by a -1/3, that's going to change the up to a down, or the 1 really into a -1/3. This one's going to change into a -1. This one's going to change into a -5/3, right? So this really emphasizes the negative that I'm going down for these values. Okay, so I'm going to go over 1, down about 1/3, over 1, down 1 or 3/3. So there's 1/3, 2/3, 3/3. Okay, and then over 1, down 5/3, 1/3, 2/3, 3/3, 4/3, 5/3, right? So I end up right on that point that I already knew was there. So I'm going to go ahead and sketch these other two in there. Oops. It'd help if I did it correctly. Over 1, down 1/3. There we go. And that's good enough for me. We will just draw that the best we can. That one turned out pretty good. Okay, example 4. We have a golf shot simulator where x is the horizontal distance in yards, y is the height, and here I have the first shot is given to me in the graph, the second shot is given to me by a function. So I'm going to go ahead and kind of sketch a graph for that second shot. And I'm not going to spend too much time on this. I just need a sketch. But what I can do pretty quickly is recognize, since this is in factored form, this tells me I have an x-intercept at 0, 0, right? Because this is, I could rewrite this factor as x minus 0. So 0 is one of my x-intercepts, and 40 is going to be my other x-intercept. So I'm going to go ahead and put those on there. I have an x-intercept here at 0, 0. I have an x-intercept here at 40. And fortunately, it's pretty easy to find the middle of that, right? So I know the middle is going to be 20, so there's my axis of symmetry. I just have to figure out how high that second shot ended up going. So I can find that. I know that x equals 20 for my vertex. To find the y value, we can go ahead and do, looks like my function's called b of 20, which is going to be negative 0.03 times 20 times 20 minus 40 is negative 20. And if we multiply that all out, we get 12. So it does not look like that goes very high, does it? It only goes up to a y value of 12. Okay, and then I can go ahead and answer my question then. Which shot travels farther before hitting the ground, and which shot travels higher? So it looks like, honestly, the first shot's both farther and higher. It went 100 meters, right? So let me highlight to show you how I figured that out. So farther, so the first shot went all the way out to 100. My second shot only went out to 40 on my x-axis. So the first shot definitely went farther. And then higher, that's going to be my y values, right? So this went all the way up to 25. The second shot only went up 12 feet. Yards, sorry, 12 yards. Okay, so let's go ahead and answer that real quick. The first shot went farther and higher. So glad we did all that work for that second shot then, and it was just the worst. Alrighty, example 5, SAT, ACT practice for free. You're welcome. Okay, we got an equation. The equation relates the variables x and y. For what value of x does y reach its minimum? Okay, a whole lot of letters there, but really we're looking for what value of x. And then keyword here is when y reaches its minimum, that minimum we have to remember is really talking about the vertex. So we just need what is the x value of the vertex. And if you have Desmos pulled up, this would be so fast. Type this equation into Desmos or your calculator and click on the vertex. Okay, just to practice for this class, let's go ahead and do it by hand using our equation. But for test taking, please do it the faster way. Just do it by graphing. So negative b over 2a, and you can simplify that in your calculator to 2405. It's not actually asking for the y value. It just says for what value of x, so 25/4. Function f is defined by the equation for what value of x does f of x reach its maximum. Again, okay, so same exact type of question. It's not actually asking for the maximum value. It's asking for what value of x. So we just need to find the x value. And I know, bad graph. This has an x-intercept of positive 10. It has an x-intercept of negative 13. We've just got to figure out what is the number that's exactly halfway between those. That's not easy for me to see on a sketch, so I'm just going to go ahead and average them, right? Halfway would be the average. That x value is going to be 10 plus negative 13 divided by 2, which is negative 3/2. Which is the x value, and that does answer the question. Alrighty, so that is all of 2.2H, and I will see you in the next video.